and today we are doing geometry. Yeah, so we are learning geometry. Or is it geometry?
No,
It's not geometry.
perimeter and
area.
yeah.
All right, so perimeter and area of 2D shapes. All right, so I'll just give my interpretation of what 2D is, né? And I'll start here. So this D stands for dimension. Now you mentioned something earlier when I was just asking you what do you think 2D is, and you said like a picture. That's more or less the long and short of it. Now to get technical, picture yourself so small that you're a dot as big as this dot, right? Now there's no dimension here. There's no length that you're gonna move in. There's no space that you're gonna travel or move in. So now let's say I'm no longer this dot, or I'm still this dot rather, but whomever made me this dot decides to give me room to move. And they give me a line, né? So a line segment. Yeah, line segment. They give me a length of segment to move along. Now on this length of segment, I'll be able to move in this way. Yeah?
Yeah.
So I'll be going from point A to point B along that line segment. But now, Maker says, oh, okay, but that's a bit limiting, man. I want to see what else Dot can think of. And then they're like, okay, Dot, you're going to have bigger area, bigger space to maneuver. But that space is going to be a projection. So in other words, that line segment, you take the length of it and you square it. Then we get an area. Because that length is multiplied by a width or a breadth. Ne? So what does that mean? It means Dot will be able to move in the same direction in one dimension that he was able to move in before. Dot is also going to be able to move in the second dimension of the space that he can navigate. So effectively, Dot will be able to move anywhere on this plane. Right? Now that's 2D space. 2 dimensions because the first dimension is here, the second dimension is there. Now beyond this, just before I carry on, when you think of area, the space on your page, that's an area. It has a long side and a wide side. The floor on which you walk, the floor in this room, that's an area. It's a floor area. The wall also has an area, it's just on a different plane. Right? This wall behind us also has an area. Now, when you combine these walls and you put them above the floor, so this would be just on your x-axis, y-axis, that would be either y-axis in y direction or x direction, right? Here, this would be along the y and x dimension, right? Now, when we take that up a notch and Maker says, okay, there's Dot there, or whomever, whatever it is that is able to make people or put things into existence. That's what I want to say. I don't want to make it religious because it's not religious class. Yeah. So there's our Dot there. It's somewhere there. And they're now given space to move on top of that initial area they occupied. Yeah? Just want to make it square. Yeah. Right? So then they elevate that area. So that area here is this one here. Now we elevate that and we have a volume. So this room that we're in, this represents a volume. It's a box, right? It's a bigger box made of bricks and I guess it has windows. So let's just say here we have a door. Somewhere there we have a window. Maybe let's put the window that side. Okay? That one. So now our dot is able, if the dot can jump, it'll be able to jump anywhere in this space. It can go out the door, it can go out the window. You see? But it can move within 3 dimensions, across a length, across a breadth or width, and over a certain height. Yeah. And what this is, it's your x is there, your y is there, and now you have another dimension, the z dimension, and this is 3D. Right? So for perimeter and area of 2D shapes, we'll just be focusing here. That's where we'll be focusing. Right? Now, I just want you to read this paragraph so that you can understand things that I might have overlooked in my explanation.
A geometrical shape having 2 dimensions, namely length and width, is called a 2-dimensional 2D shape.
Excellent. So you see, it corroborates the theory that we've just shared now. Yeah. So, okay, just read the next part because I think that it has important words that are used in math that you might find in an exam, and because they're not like layman English like I'm saying, they might be confusing. So I want you to be familiar with them. Okay?
It is sometimes also called plane or planar figure. A 2-dimensional shape is called a simple closed shape if it divides the plane into exactly 2 regions, a region inside the shape and a region outside the shape.
Okay, so it's a closed shape because if we imagine our dot inside the shape, the dot will not be able to go outside of the boundary. We can't go, unless the door is open, we can't go outside of the floor space or outside of the room space. Yeah, so it's a closed space. That's what is meant there. Okay. Okay, the next paragraph.
In grades 7 and 8, you learn that a polygon is a simple closed shape. The perimeter of a polygon is the sum of lengths of the sides.
All right. Carry on.
The perimeter of a circle is called the circumference. The circumference of the circle.
Okay. So hold it right there. And then I just want to finish writing this now. Alright, oh yeah, next slide. So you know you click there now. Awesome. So when we have a shape, a polygon, let's say we've got a 5-sided figure, a 3-sided figure, and even a 4-sided figure. As long as it's closed meaning there are joints that are meeting points for all of the line segments that make the shape. That's closure, né? If our little dot, for an example, was to move around that boundary, like that, that would be the perimeter, né? So I don't know if you've played Call of Duty. You have, all right? Or movies that have to do with some military action, right? They usually talk about the perimeter. Yeah, so that just means the boundary, perimeter, right? So where everything is happening, within where everything is happening, right? So perimeter would be the sum of the lengths. So if this is 2 and that is 1 and that is 2 and that is 1, that would be 2 plus 1 plus 2 plus 1. All of those numbers, when you add them up, they give you the distance you would cover if you walked around the perimeter. Your yard, for example, that's also a perimeter. The distance from the one corner in the house to that one in etc. That's also perimeter. Same as with a multiple-sided figure beyond 4 sides. Now with a circle, it's called circumference. So this part of the word circumference simply tells you that you will be going around in a circle. So the word circle also has its root there, right? And it's the distance, if you were to go around, that you would walk there. Think about in the middle of a soccer pitch. That the in Sutra, I guess that means the belly button of the soccer pitch. Yeah, so that circle there, that big circle, if you were to walk around it, that would be the circumference. So that's what is meant there. Okay, the next paragraph I think is quite important.
Length is measured in terms of the SI units derived from the French system international D units.
Okay, I wouldn't be worried about pronouncing System International d'Unité, right? Because I probably don't have the correct French pronunciation as well. So, carry on.
The units are kilometer, km, hectometer, hm, decameter, gm, and meter, m, centimeter, cm, and millimeter, mm.
All right. So the base unit for measuring length, the dimension of length, is meter, right? So a meter is about I'm trying to think how how long a meter could be. 297, so that's 369. So these books, the longest side is 297 millimeters long, right? So that's almost 300 millimeters. So 369, maybe up to here, give or take, that would be a meter long, right? So every other dimension, or rather unit of length, that is derived from meter, whether it's small like millimeters or large like kilometers, is derived from there. And now on our scale, we would have meters here, then we would have centimeters, I believe.
Yeah.
Centimeters, I think we have decimeters, or is it decimeters? Yeah, it's decimeters first, because decameters, sorry, decameters. Deca from 10, like a decade, and then centi for 100, yeah, centimeter for 100, like century, and then milli, as in millennium, so 1,000, right? So this is 1 meter. Let me write it now. Ne? So this would be okay. So this would be 1. This would be deca, meaning a tenth of. So 1/10 of a meter. This would be 1/100 of a meter. And this would be 1/1,000 of a meter. And then you have hectometer, I believe. And hectometer would be 100 times this, ne? So it'd be 100 times, and then kilometer would be 1,000 times the meter. And then, we also have micrometer. Ne? Some things are so small, even with a microscope, they're very small. So you measure them in micrometers. And others are much, 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 much smaller. And the units go as far as there's something called angstrom. But I wouldn't worry about that now because it's a bit sophisticated and you learn that in varsity. But let's just stick with these ones because we can easily appreciate them, right? So how many meters is it from here to town? If that's a meter. And how many meters is it from here to town? It's quite a lot, right? So because you'd have to fill up a lot of space on paper, writing 8,000 meters, you'd much rather say 8 kilometers. You get it? So 8 kilometers would be 8,000 meters, right? Okay. And then in chemistry, you will learn that volumes of substances are calculated in this unit cubed. So decameter cubed, right? And that makes it easy because 1 decameter cubed is the same as 1 liter. So it makes it easy like that. But we'll get to that. But that's the long and short of the units. So what this table here is showing us is how to convert units. Ne? So if 1 kilometer is 1,000 meters, then it would be 1,000,000 millimeters. So that would be 8 million millimeters. Right? This would also equal 8 kilometers would be 8,000 meters. And I don't know, how much would that be in terms of if 1 centimeter is 100 cent. So if 1 meter is 100 centimeters, then 8,000 meters would be 8,000 times 100, which would be 80. It's 8,000. So 800,000 centimeters. Yeah, that looks right because the 800,000 is a bit less than millimeters because you'd have more millimeters in a meter than centimeters. Yeah. So this is just a conversion exercise. You can give yourself this as an exercise just so you can get familiar with the conversion. And I think the next paragraph will speak about area. So just read that paragraph, and then from there we'll just look at some of these examples.
In geometry, we use the term area in association with the magnitude, size of a bounded region. We express the area of bounded region in terms of the number of square units covered by the particular bounded region. These are the metric SI units for area that are mostly used.
Okay, good. Well done for that. So area, remember what I said that in the first slide, ne? Remember what we spoke about in the first slide. I'm just gonna take us back there. What we spoke about was that it's two-dimensional and it's a projection of that line going in that direction. So because it will be a closed shape and it's projected, then it is that space there, the measure of that space there. And now it's squared for the simple reason that it is the length of the one side times the length of the other side. Now we can also think about this from the perspective of units. So I'll make another sketch just to show. So let's make another sketch just to show, ne? So the length of this one segment, let's say it's 2 meters. Let's just draw a rectangle. And then the length of that other line segment is 4 meters. Going up, that is also another 2 meters. And then we close the shape to have a geometric shape, a rectangle, right? Now that length is 4 meters. Right, so this is a rectangle. It's closed because there's no space between the corners. If it was an open shape like that, it's not a geometric figure. It's just a line, series of line segments. So now, the perimeter would be the length. Let's call that A, let's call that B, let's call that C, and let's call that D. So this is the length, and this is width. Would be A plus B plus C plus D. And when we add those, it'll be 4 plus 4 meters plus 2 meters plus 4 meters plus 2 meters. And the answer would be 4 plus 2 is 6, plus another 4 is 10, plus 2 is 12. So the distance you would walk around would be 12 meters if you were to go around. But now the area, remember it's in square units, right? That is because it is the product. Product is the answer you get when you multiply two or more numbers together. Sum is the answer you get when you add two or more numbers together, right? So sum, answer from adding two or more numbers, and product is answer from multiplying two or more numbers together. Yeah? So now area would be length times width or breadth. And this would be 4 meters by 2, and that gives us the space that is projected there. The space that is projected in this way. Or you can think about it going that way, it doesn't matter. But it is this space here. That's the area. Yeah? So 4 meters times 2 meters. Now, I want you to think back to factorization and exponents, right? Remember when we multiply, we're going to have 4 times 2. And that gives us how much?
4 times 2.
Yeah.
9.
Mm-mm.
9.
4 times 2?
9.
No. 9 is an odd number. You can't get an odd number by multiplying two even numbers together.
How is this?
Take your time. Take your time. If I'm multiplying even numbers together, I will always get an even number. In fact, yeah, I think that's the case, yeah. But I'll have to check that. But for now, I think that that's true. It's 8. Well done. But now, check here. 4 times 2 is 8. But now we have the meter times the meter. And what's that going to happen? What's going to happen with that? What do you think is going to happen? Remember I said factors and exponents. I'm going to have 8 meters squared. Yeah? Yeah. Again, with volume, you will also have a similar thing, but volume, the units are in cube. So it'll be m to the power 3. So if you want to work out the volume of the room that we're in, it'll be however many meters there times however many meters the long side times however many meters from top to bottom. And the product of all of those dimensions, m times m times m, would be 1m to the power 1 plus 1 plus 1, and that's cubic meters. So those are cubes. That is why the shape that looks like a dice is called a cube. Ice cube, it's got length, width, and height. Yeah, that's why they're cubed. So here it's a square area. That one. So when you think about it, here it's exponents and factors at the same time. Yeah, that's what happens. So that's what they mean by all of these. Ne? So familiarize yourself with these units. Because if you get to a point where you get so rich you can afford to buy a farm, that area is going to be calculated in hectares. And hectares is 10,000 square meters, meaning it's 100 meters by 100 meters. So it's 1 hectare by 1 hectare, and the area there is called a hectare. Right? The area of South Africa or many other countries is usually expressed in square kilometers. And that unit is important because if you have to discuss the population density of a place, for example, when you go on the internet, let's say you go to the CIA fact sheet about countries, they will tell you the population density of a certain country is so many people per square kilometer. What that means is if you take 1 kilometer distance times 1 kilometer distance, how many people are in there? So I'll just make, so population density, it's number of people per square kilometer, right? So this is where we use area. We use area to estimate population density. So if you have 1 kilometer by 1 kilometer area, how many people are in there? And there's a ton of information about this across many different sources, right? But that's one application for area. Farm sizes, like I mentioned, let's say you are interested in buying a farm or you're inheriting a farm, or let's say and they have to claim land from the government. Ne? Then that's in hectares, which are 10,000 square meters. So in other words, 100 meters or 1 hectare meter times 100 meters. Right? Let's see. Yeah, that's just one of those things. Okay, so you'll just read through these by yourself, but I just want you to read this paragraph here in grade 7 and 8. What do they say? Because I think it might have something important.
You also learned how to calculate the areas of the following polygons. Rectangle, square, parallelogram, and triangle.
Okay.
The formula are area of a rectangle equals length times breadth.
Okay.
Area of a square equals length times length equals length cubed.
Squared. Remember, areas are squared.
Area of a parallelogram, base times height equals breadth times height.
Base times height, yeah.
Oh,
Yes. Carry on.
Area of a triangle equals 1/2 bracket base times height.
All right. Right. So here, they're just showing us how we use area formulae to calculate the areas of certain shapes right? Now a rectangle, like we did in the previous example, the perimeter would be 2 times the length plus 2 times the breadth. So maybe let me not write it like that. Let me write it like L plus B plus L plus B. We've got like terms, so that's 2L plus 2B, or 2 into L plus B. Doesn't matter. Any one of those is correct. But the area would be L times B. For square, where all the sides are equal, it will be L plus L plus L plus L. 4 like terms, so it's 4 of the same. But the area would be L times L, which is L squared. All right? Was it not? I think my chalkboard lost signal there. Yeah. There we go. Now, with a parallelogram, the lengths of the sides could be different, but you still add the different sides together. And I guess for a triangle, it's also the same, right? The perimeter would be A plus B plus C. But now the area would be the breadth times the height, or the one side times the perpendicular height. And the cool thing about a triangle is that a triangle can be thought of as half a parallelogram. So its area would therefore be half of the parallelogram. Now that's just a cheat sheet I would give you like that off the bat. But keep these formulas in mind, or these formulae in mind, because they get very useful. Yeah? And the nice thing about your grade 9 textbook is that it reminds you that you learned these in grade 7 and 8. So always keep that in mind, that you're not supposed to be learning this first time. It's something that came from 2 grades before. Yeah. So I noticed that maths tends to get difficult at the grade that you're in, because maybe the grade before or 2 grades before, there wasn't a good foundation for that. And I don't know if you've seen how houses are built, but every house has a foundation. And if that foundation is not strong, the house is going to collapse. That's just how it is. Yeah, so I think that's enough of reading. Let's quickly do these examples where we convert. Ne? All right, so conversions. Conversion exercises. All right, cool. They say we must convert these measurements to meters. So convert to meters. The first one is 1,000. Wait, is it 1 or it's 1.076?
0.
Oh, no, yeah, 1.076 kilometers.
Yeah.
Okay. And then the second one is
0.43
hectometers.
Yeah.
Okay. So when we are reading decimals like this, we don't say 43. That's for numbers that are not behind a comma. When we read out loud numbers that are behind the comma, we call each number on its own. So 1 comma, this number would be 1 comma 076. This one will be 0 comma 43. That's how we call them out. Because 43 means we have 40 of a number plus 3. So that's 43. But if it's behind a decimal, it's not the same as that one. So you call it out on its own. So it's 4, 3. Yeah. So just keep that in mind. And then C would have
202.7
millimeters, yeah?
Yeah.
Okay, so remember, every kilometer has 1,000 meters. So if we convert 1.076 kilometers to meters, means we have to multiply by 1,000. So when we multiply by 1,000, that's how we do it. Né? We say 1.076 kilometers will equal 1.076 kilometers times 1,000 meters per kilometer, right? So that's how we do it. And now what's going to happen? We are going to have remember we talked about additive inverses in our last class. Now there's something else called multiplicative inverses. Additive inverses have to do with what do I do to a number, what do I add or subtract from a number to get 0, and multiplicative inverses are what do I multiply a number with, or what do I divide a number with so that I can get 1. And how that works, like I put here, 1.076 kilometers times 1,000 meters per kilometer. And this gives us multiplicative inverse, where that kilometer divides that kilometer out to give 1. And we're only left with the dimension, or rather the unit of measurement of meter, right? So this would be 1.076 times 1,000. That means the comma shifts 1, 2, 3 times, and that just leaves us with 1,076 meters. So that's how we convert it. You see? So I was very deliberate, I was very intentional with writing meters per kilometer, because in 1 kilometer we have 1,000 meters. So that's why it's 1,000 meters per kilometer, so that the kilometer unit will divide the kilometer unit out, and I'm left with 1, and then the meter stays behind. And that's how I convert 1.076 kilometers to 1,076 meters. For B, 0.43 hectometer. Remember we said a hectometer is 100 meters, right? So to meters, that would be 0.43 hectometer times 100 meters in a hectometer. Now those two divide each other out to give 1, and the comma here, so 1, 2, 3. So here the comma would shift 1, 2 times, and I'm left with 43 meters. Is that what the answer is? Yes, it is. All right. Now the third one, 202.7 millimeters, and that would equal 202.7 millimeters times how many? Oh, yeah, times 1/1,000 meters per millimeter. And the same thing happens with the units. And then this is going to be 202.7 divided by 1,000 meters, and that gives me, so the comma will shift 1, 2, 3 ways to the right. So to the left, 3, and that gives me 0.2027 meters. Yeah, so I making these comma shifts just to show you that the zeros also like the number of zeros you multiply by indicates how many times the comma will shift. Yeah. So it's a neat trick that you can always remember, but it's very helpful if you do it right. It's very helpful if you do it right. Now I think that's everything.
So far.
Are you understanding so far? Okay, I'm glad. I just make for us the next slide so we can do this example of parallelogram. Yeah. Yeah, sure. Ask. Oh, you're still taking down notes. That's good. But okay, take down notes. I think it will help you also to assimilate the knowledge on your own. But also remember, when you get the chance to access these on Classroom, I sent you the invite, so you will get them as soon as you accept the invite. Yeah. And you get them for life. So as long as you have an email account and you're still using it, you'll have access to it. You still remember your password, right?
Yes.
Okay, cool. All right, let me know when you finish. You're done. Awesome. Do the next slide. Yeah, so another example. We have a parallelogram, yeah? Thanks. And it's got diagonals. Let's close the shape there. Oh, I drew it the other way around. But if I get the dimensions right, it's the same thing. Oh, it's actually a rhombus. Interesting. So this side here is 5 centimeters long. Bless you. This side here is 12 centimeters long. Okay. And the base length oh no, incorrect. The perimeter and height of a rhombus with a base length of 6.7 centimeters and the area is 40.2 square centimeters. Okay, so we must, square centimeters. So this is what's given. So we must find the perimeter and the height. Find perimeter and height. How would we do that? Interesting. We know the area of the perimeter, of the rhombus. Yeah. So let's just do this. So let's say our solution. We know the area. It equals 40.2 square centimeters. But we also know that the area of a rhombus, which is a parallelogram, it equals the base times the perpendicular height. Ne? Because the area of a rhombus is B times H. And since we have B, we can substitute that as 6.7 centimeters. But we don't know the height, so we'll just leave it as h there. Yeah? Then the next thing we can do is we can apply multiplicative inverses to both sides. So that means we divide both sides by 6.7 centimeters, so that 40.2 square centimeters is divided by 6.7 centimeters. That equals 6.7 centimeters times h divided by 6.7 centimeters. We will have those give us 1, and we're just left with h on the one side, and we have to divide 40.2 by 6.7, which will give us 40.2 divide by 6.7, which will give us 6. So that means the height is 6 centimeters. Ne. 6 centimeters. And we also need to include the units, because if we don't, then it's chai. Yeah. Whew, okay. Rhombus. We have your area, we have your height, we have your base length. Now, about a rhombus, do you know the properties of a rhombus? Okay, let's quickly remind ourselves of the properties of a rhombus. A rhombus is a special type of parallelogram, né? Where each of the sides are equal, right? And if all of the sides are equal, then it means that this distance here equals that distance there, equals that distance there, and that equals that distance there. Essentially, so basically, the perimeter would equal 4 times the base length, which is 4 times 6.7, and that equals let me just say 4 times 6.7, that equals 26.8 centimeters. So if we were to walk around, we're so small that we could fit here, and we were to walk around the perimeter, we would travel a distance of 26.8 centimeters. Yeah. Yeah. And the last problem that we can look at for the evening before you go do self-study, we have a quadrilateral, that is a rhombus. Given a rhombus, and our rhombus looks something like this, yeah? Okay. It looks something like that. All right. And we are only given the distance here, which is 5 centimeters, and the distance there, which is 12 centimeters. Okay. Remember, a rhombus has got all the sides equal. That's one. But also, all of the diagonals, both of the diagonals, they cut each other in half, right? So the diagonals of a parallelogram cut each other in half. But for a rhombus, when they cut each other in half, then they're all equal. No, they're not all equal. Sorry. What it also means is we would have 12 centimeters there and another 5 centimeters there. Yeah, that's what that means. Yes. So we could work out so in order for us to work out the perimeter and area, we'd have to be very creative. How do we get creative here? Oh yeah, I just remembered. And I got a hint from the other page. So remember, we've got a right angled triangle. Oh yes, the diagonals of a rhombus cut each other at 90 degrees. Yes, that's the important thing. The diagonals are cut in half, so they're equal. So this would be 12, that would be 12. But also this would be 5 and that would be 5. But where they intersect, it's at 90 degrees. Now when we have 90 degrees, we can, and a triangle, we can use Pythagoras. So in Pythagoras theorem, which is the length of the hypotenuse squared equals, or rather, c squared equals a squared plus b squared. So we'll call that a and we'll call that b, so that will be c, right? So in this triangle, we would say c squared equals a squared plus b squared. So that would mean c squared is 5 squared plus 12 squared. And that would mean it's 25 plus 144, which is c squared is 169. Therefore, c would be the square root of 169, which is 13 centimeters. Right? So this here is square centimeters, just by the way, because we squared everything. So now to get the perimeter would be 4 times the length c, which is 4 times 13 centimeters, which is 40 plus 12, 52 centimeters. So the distance that would be traveled all around the perimeter would be 52 centimeters. And then now to get the height, how do we get the height? I would do this in several ways, in one of several ways, but one of those several ways being, I'll work out the area of one triangle, and I think it would be the same for 4 of them, right? So area of one triangle would be a half times the base times the height. And I'll take the 12 centimeter length as a base. And I'll take the 5 centimeter length as a height. And that will be 12 times 5 is 60, times a half is 30. But now, because each of these triangles are equal, then the area of the rhombus would be 4 times the area of the triangle, which is 4 times 120 square centimeters, which is, 30, not 120, which is 120 square centimeters. I think that's the correct one. Otherwise, I'm misleading you. Yes. Yeah, that is correct. But you can follow the example and try and figure out how they got to the answers. Yeah. All right, so we'll end here. I can see you're already tired.
Oh, it's my
Your tooth.
yeah.
Okay. So perimeters and areas of composite shapes. Still follows the same way of thinking, but this time you would have to break apart the shapes into different shapes. And in some cases where you have a rectangle inside a circle and they say find the area of the part that's not a rectangle, you'll have to find the area of the rectangle and subtract it from the area of the circle. So it's like a negative area. Right? So we'll do those okay, in the next lesson when we continue with this area and perimeter, and that will be everything. Yeah. But are there any questions for today?
No, sir.
None. Okay. So we finished quite early. Thank you for coming, and I'll see you next week Tuesday.